Welcome back to mining of massive data sets. In the previous lecture, we looked at collaborative filtering approaches for recommender systems. In this section, we're going to look at how to evaluate a recommender system to make sure that it's doing a good job. Let's look at an example. Suppose we have a set of users and movies, users on the y-axis, movies on the x-axis, and here's a utility matrix that gives, where some of the rating values are known and some are unknown, and ratings are on a scale from 1 through 5. Now, the common evaluation methodology is to take a piece of the matrix and treat that as a test set. Now, we know these ratings, but we're going to withhold them from the algorithm that we're going to use. So we'll call this the test data set or the withheld ratings. And we'll, for the purposes of the algorithm, these are going to be treated as the same as unknown ratings or the blank ratings. But in fact, we know what these ratings are, so we can use our algorithm to predict these ratings and then compare them against the actual ratings and see how good the algorithm performed. So the trick is to compare the predictions against the withheld known ratings or the test set T, and the most common measure is a measure called the root mean square error, or RMSE for short, and it's very simply defined, as the sum of the squares of the deviations from the actual ratings and the predicted ratings. So in this case, RXI star is the actual rating for user X and item I. RXI is the rating that's predicted by our algorithm. We're going to take the difference of those two and square it, and sum of those squares across all the withheld ratings and divide by the total number of withheld ratings, which is n, and just take the square root of that. So this is the root mean square error, or RMSE, and it's the most commonly used measure to evaluate a collaborative filtering system. Now, while RMSE is a very, very simple measure, it does have a few problems. And one of the most common problems is that this narrow focus on accuracy, or RMSE, sometimes misses the point of why we implement a recommender system in the first place. Remember, the goal of a recommender system is not really to predict the rating of a user for a given item, but to recommend items to a user that the user might buy or might view or might listen to. And therefore, sometimes when you predict just the items with the highest scores or the highest similarity, you might end up with problems. The first problem we run into is the problem of prediction diversity, which means that all the predictions are too similar to each other. For example, let's say the user liked the first Harry Potter movie. Now, the set of most similar items to that, or the set of items with the best scores, might be the other Harry Potter movies. So all the predictions might therefore be Harry Potter movies, which is rather non-diverse set of recommendations and might not introduce the user to any new and interesting items. The second problem is one of context. Now, the user might the same user might be operating in different contexts and might want different items in those contexts. For example, let's say a user is traveling to Patagonia. He might end up shopping for lots of travel books on Patagonia. Then once he's back from Patagonia, the set of recommended items will include more books on Patagonia, which the user is not interested in anymore because the user is in a very different context. Finally, the order of predictions also turns out to be hugely important. For example, when there's a series of books or movies, you want to recommend items that are earlier in the sequence ahead of items that are later in the sequence. Note also that in practice, we only care to predict high ratings, right? So we've sort of set up this whole problem of predicting the rating of a user X for an item I. But in practice, we don't really care what the rating of user X for item I is if that rating value is low and the user really doesn't like the item. We are only going to recommend items to the user that the user really cares about. And so we only care to predict high ratings, not to predict low ratings. And the RMSE that we've sort of defined, the root mean square error, actually doesn't distinguish between high ratings and low ratings. It only looks at the difference between the actual ratings and the predicted ratings. So in fact, we might come up with a method that works well in practice, that recommends really good items to users, but actually makes bad errors on items that the user doesn't really like. Now, this algorithm might work really well in practice, but its root mean square error evaluation will look really bad. So an alternative method that actually captures this idea is to use a metric called precision at top k. So let's say the user, we look at the withheld ratings of the user, but only look at the highest k ratings in the withheld set for a given user, and see whether our algorithm can predict a large fraction of those items. So the precision at top k is just a percentage of the predictions that are in the user's top k withheld ratings.